Optical fiber sensors are used to measure magnetoacoustic, pressure, temperature, acceleration, gyroscopic displacement, liquid level, torque, optoacoustic, current and strain, and other physical quantities. In this lesson, let's learn the applications of optical fiber temperature sensors, working principles, applications of optical fiber liquid level sensors, as well as the optical fiber turbine flow meters. The distributed optical fiber temperature sensor is a recent advancement in high technology, which is used to measure the spatial temperature field in real time. The distributed optical fiber temperature sensing system not only has the advantages of common optical fiber sensors, but also has the ability to sense the temperature distribution at various points along the optical fibers. Using this characteristic, the temperature of each point within several kilometers along the optical fiber can be continuously measured in real time, and the positioning accuracy can reach the order of meters, and the measurement accuracy can reach the level of 1, which is very suitable for large-scale focused temperature measurement. Next, we will learn the structure and working principle of optical fiber liquid level sensors. The structure of the optical fiber liquid level sensor is shown in the figure. The sensitive elements of the sensor and the optical fiber for transmitting signals are composed of glass fibers, which have the advantages of good inherent insulation performance and anti-electromagnetic noise. The working principle of the optical fiber liquid level sensor is shown in the figure. The light emitted by the light-emitting device is sent to the spherical sensitive element at the other end through the transmission optical fiber. On the spherical surface of the sensitive element, some light is transmitted, while the rest is reflected back. When no liquid in the container, the transmitted and the reflected light remain constant. When there is liquid in the container and the sensitive element is in contact with the liquid, the light transmission amount on the spherical surface increases and the reflection amount decreases compared with the air contact. Therefore, the contact between the sensitive element and the liquid, as well as the liquid level, can be determined through the analysis of reflected light. The amount of light emitted depends on the refractive index of the sensitive element glass and the refractive index of the measured substance. The greater the refractive index of the measured substance, the smaller the amount of reflected light. The reflected light from the sensitive element passes through the transmission optical fiber, and photovoltaic conversion is made by the phototransistor of the light receiving device. This method can be used to distinguish the substances of water and oil, which has great differences in reflected brightness. After that, we will learn the applications of optical fiber liquid level sensors. Moisture exists in the bottom of gasoline or clear oil diesel tanks due to accidents or condensation from the air. In order to avoid accidents, it is necessary to detect the moisture in the tanks, and then clean or drain water. In this case, it is most suitable to use optical fiber liquid level sensor without explosion danger. When oil and water exist in layers, the surface of oil and the interface between oil and water can be detected by using the sensor. When the amount of oil increases, the sensitive element 1 is inserted into the oil, and the amount of reflected light decreases. When the amount of water increases, the amount of light reflected by the sensitive element 2 increases after changing from the oil surface to the water surface, so it is known that the sensitive element is immersed in the water. Finally, we will study the optical fiber flow meter. Based on the principle of traditional turbine flow measurement, optical fiber flow meter is a reflective turbine flow meter, which uses multi-mode optical fiber instead of internal magnetic sensor. A pair of reflective optical fibers and photoelectric conversion circuits detecting the rotation of turbine blades are shown in the figure. The reflective optical fiber sensor is composed of multi-mode glass fibers, including light-emitting fiber and light-receiving fiber. The detection end is fixed in an aluminum alloy sheath, which can be installed on the turbine flow meter instead of the internal magnetic sensor. When working, the emitting fiber emits light on the end face of the blade, and the rotating turbine blade periodically reflects, while the receiving fiber receives the reflected signal of modulated light, which is filtered and converted into a flow pulse signal, and its frequency is proportional to the rotating speed of the turbine, that is, proportional to the measured flow. The flow rate of the measured fluid can be obtained by further processing the signal. Compared with the traditional turbine flowmeter, the optical fiber one has obvious advantages. 1. The traditional internal magnetic sensor in turbine flowmeter can only detect the rotating speed of blades due to its structural limitation. The reflective optical fiber sensor is small, so two reflective optical fiber sensors are able to be assembled on the turbine flowmeter in parallel, so that the two sensors can detect the reflected signals at different positions of the same turbine blade without interfering with each other. 2. Compared with the traditional turbine flowmeter, the optical fiber one has good linearity, good repeatability and stability, strong anti-electromagnetic interference ability, and large range ratio. The experimental results show that the range ratio is as high as 1 to 400 when the resistance moment caused by turbine viscosity is not considered, while that of traditional turbine flowmeter is only 1 to 60. This is mainly due to the optical fiber sensor, which avoids errors caused by the magnetoresistance between the internal magnetic sensor and the turbine blade at low flow rates. Additionally, it overcomes the problem of signal saturation of the internal magnetic sensor at high flow rates. 3. The modulated optical parameters of the optical fiber sensor can also be changed according to the requirements of the overall design. Applied to different occasions, it provides convenience for turbine design. In this lesson, we've learned the application of optical fiber temperature sensors and the working principles and applications of optical fiber liquid level sensors, as well as the optical fiber turbine flow meters. You can consult the materials after class to understand the further applications of optical fibers. That's all for this lesson. See you next time.